back. Now we're going to see how we are going to do it in LabVIEW. Okay, so to do this in LabVIEW, I'm just opening my LabVIEW block diagram. Okay, so just follow this sequence of operation. This block diagram is applicable for any kind of serial transmission. Okay, so what I need to do is first I need to have a just a minute. Okay, just I've taken up my mouse. Okay, so I'll just go into the instrument IO. Okay, I right click in the block diagram. I go to instrument IO. I'll just go into this particular thing called as VISA. Okay, so what is this VISA? So VISA is actually called as Virtual Instrument Software Architecture. VISA is called as Virtual Instrument Software Architecture. Okay, basically what this VISA does is this VISA helps you in communicating. I'll just tell you what is the role of VISA. Okay. Okay. Just we'll see what the VISA does before actually we continue. So VISA is Virtual Instrument Software Architecture. Instrument Software Architecture. It's something like it's a visa, simply visa. Okay, whenever you want to travel to foreign countries, you get visa, right? In a similar manner, whenever we want to have different kinds of transport or different kinds of communication, then visa is the best choice. Okay, so what does visa does? Suppose if there is no visa, I'll tell you what is the scenario without visa, so that you can understand better what is the role of visa. So you develop a program in C, say. Okay, you develop a program in C for a particular kind of a communication, say for a serial communication you develop a program. Okay, and it works with an hardware, fine. Okay, now you suddenly want to change this program for say Ethernet communication, or you want to change this program for a parallel communication. Then every time you need to change the coding, you have to include the appropriate binary files and the entire the way in which you get the data, all those things changes. Okay, but in VISA, advantageously, we don't need to worry about what is the mode of communication, because VISA will take care of the communication aspect. Whether it is a serial communication, whether it's a GPIB, whether it's an Ethernet, it is going to take care. But you have to configure the VISA correctly. So if you know how to configure VISA, then it is independent of the kind of communication. So the same program that I'm going to show you now will work for serial, it will work for GPIB, it will work for Ethernet, provided all these are faceless instruments. All these are faceless. What I mean by faceless is I have a naked piece of hardware. Okay, so this hardware I'm just going to control it with the software. As long as this condition is met, we can use this same program with any kind of hardware. Okay, that's a basic idea. Okay, so now we'll come back to our LabVIEW and see how this processing is done. Just open my LabVIEW. Okay, so what I need is first I need to configure my session. Whenever I want to configure my session, I need something called as VISA open. Okay, I need a VISA open. So when in this VISA open, I need to configure the different parameters of VISA open. So visa open, I right click, you can see on the top right corner. So to help you better, I'll just open an contrast help window. In this LabVIEW, if you have this contrast help, you can see very much what is very much required, the darkened one, visa resource name. Okay, so here I connect create a control, so visa resource name. Okay, so when I just go into the front panel, okay, the shortcut to go into front panel is Control E. Here you can see this visa resource name on the top. It will be a drop down menu. If drop downs, you can see all the ports that are available. Okay, so if you remember from the Arduino, we have taken COM10 port, so I'll select the COM10 port. Okay, so back in block diagram, so we have the visa open here. So next thing, we are going to write some data into it. Okay, so I need a visa write for this purpose. So for visa write, it requires two properties. One is a resource name and the second one is write buffer. Resource name tells you from where the data comes. Okay, so I'll just connect the visa resource name to the resource name out of the thing. Okay, and of course, whenever I want to close the operation, I need a visa close. Okay, so this will be the closing. Now we will see what to write. So into visa write, you have something called as write buffer. Okay, previously in I told you what you'll be doing. So we have to whenever we switch on, I have to send a letter A. Whenever switch off, I have to send a letter B. That's what we are going to basically do in LabVIEW. So what I'll do is that I'll go back to the front panel. Okay, and I'll make a switch. I'll make a small switch. This will be my switch from the hardware. From the software side. I have a switch, fine, and also I'll have an local LED. This will be a local LED to just display, make the LED glow in the screen. Okay, so the main thing is it has to glow in the hardware. Okay, but we are using it for a local display. Black in my block diagram. So this is my local LED, fine. Okay, now what I'll do is that I'll open up switch case structure. This is a switch case structure here. Okay, so I'll give this operation of the switch to the switch case. So what I mean by switch case is I have two options, either the switch is on or the switch is false off. Okay, so when it is on, I have to send a letter A. So I'll go into by string operation, I'll choose a constant and I'll choose A. Okay, so this has to go into my write buffer. Okay, so I'll just remove these blocks. It actually goes via this one. I'll remove all these wires. It's a kind of a messy. I'll do again. So this is my visa A. I'm just taking it out. Okay, so this goes into the write buffer. Clean, right? Now this is a local LED. Whenever this particular LED from my Arduino glows, at the same time I want this LED to be on. Fine. So what I'll do is I will choose a string constant for this purpose. I'm going to choose a string constant. I'm just connecting it to the thing. Okay. Now I'll go into the false case. So I will create a constant. I'm going to type in B. And at this point I'm going to type create a constant and I'm going to give a false. Fine. Almost the program is complete. I'm going to do some closing operations. I'll again go into the while loop. This part alone I'm going to enclose into a while loop because every time I don't require visa open and close to be running. Okay, and I don't need a shift register also. Okay, so I'll just I'll remove this shift register and I'll just replace it with the tunnels. Tunnels will do the job. Okay, so here I'll just create a control. I have a stop button and also I'll create a small delay. Okay, so whenever we are working with real-time instruments, we need to give some kind of a delay for synchronization purpose, and we'll create a delay of say 500 milliseconds. So 500 millisecond delay will do. Okay, so the program is pretty well completed. Okay, so we're going to use this hardware and you're going to test it. I'll be back in my block diagram front panel. Okay, so now I'll just go into run mode. So you can see I have a switch, I have a local LED. So when I press this switch, this LED in the hardware should glow, right? So I press it on, local LED is glowing, as well as you can see the LED that is glowing in this hardware. Off, it is off. On, it's on and off. Okay, so that's basically how we are controlling hardware from a software. Okay, so this is my block diagram. Okay, so this is a simple serial control. We are doing only a serial transmission in this case. Okay, so that's how you do a serial case. So what is required is a visa open, visa write, visa close, and most importantly the resource name. So in resource name we have to select the appropriate instrument. Okay, so that's the story. Thank you.